coagulation pathway and its abnormalities. The coagulation pathway, also known as the blood clotting cascade, is a complex series of events that occur in response to vascular injury to prevent excessive bleeding and promote wound healing. It involves the activation of various proteins and the formation of a blood clot. There are two main pathways involved in blood coagulation: the intrinsic pathway and the extrinsic pathway. These pathways converge on a common pathway to ultimately form a blood clot. Intrinsic pathway. 1. The intrinsic pathway is initiated by factors within the blood itself. 2. It begins with the activation of factor 12, Hagman factor, upon contact with negatively charged surfaces, such as exposed collagen in damaged blood vessels. 3. Activated factor 12 converts factor 11 into its active form, factor Xa. 4. Factor Xa then activates factor X, forming factor Xa. 5. Factor Xa, along with factor 8, which is activated by thrombin and other factors, forms a complex on a phospholipid surface, known as the tinase complex. 6. The tinase complex converts factor X into its active form, factor Xa. Extrinsic pathway. 1. The extrinsic pathway is triggered by tissue factor, also known as factor 3, released by damaged cells outside the blood. 2. Tissue factor binds to and activates factor 7, forming factor VIIA. 3. Factor VIIA, in the presence of calcium ions, forms a complex with tissue factor, known as the extrinsic tinase complex. 4. The extrinsic tinase complex activates factor X, converting it into factor Xa. Common pathway. 1. Once factor Xa is formed, it combines with factor V, calcium ions, and phospholipids to form the prothrombinase complex. 2. The prothrombinase complex converts prothrombin, factor 2, into thrombin, factor Ia. 3. Thrombin then acts as a key enzyme in the coagulation cascade. 3. It converts fibrinogen, factor I, into fibrin, insoluble fibrin strands. 4. Fibrin strands form a meshwork that entraps blood cells, platelets, and plasma, forming a stable blood clot. 5. Thrombin also amplifies the coagulation process by activating factors V, 8, and 13, which further strengthen and stabilize the blood clot. Fibrinolysis. 1. Once the wound is healed, the blood clot is broken down through a process called fibrinolysis. 2. Plasminogen, present in the blood, is converted into plasmin by tissue plasminogen activator, TPA, and other activators. 3. Plasmin breaks down fibrin into fibrin degradation products, dissolving the clot. There are several abnormalities that can occur within the coagulation pathway, leading to various bleeding or clotting disorders. Here are some examples. 1. Hemophilia. Hemophilia is a genetic disorder characterized by the deficiency or absence of certain clotting factors, typically factor 8, hemophilia A, or factor X, hemophilia B. This results in prolonged bleeding and poor clot formation. 2. Von Willebrand disease, VWD. VWD is a genetic disorder caused by a deficiency or dysfunction of von Willebrand factor, VWF, which plays a role in platelet adhesion and stabilization of factor 8. This can lead to abnormal bleeding, particularly from mucous membranes and after surgeries or injuries. 3. Disseminated intravascular coagulation, DIC. DIC is a condition characterized by widespread activation of coagulation throughout the body. It can be triggered by various underlying conditions such as sepsis, trauma, or certain diseases. DIC leads to the consumption of clotting factors and platelets, resulting in both abnormal bleeding and clotting simultaneously. 4. Thrombophilia. Thrombophilia refers to a group of conditions that increase the risk of excessive clot formation. It can be inherited or acquired. Examples of inherited thrombophilias include deficiencies of antithrombin, protein C, or protein S, or mutations such as factor V Leiden mutation or prothrombin gene mutation. 5. Anticoagulant medication effects. Certain medications, such as warfarin or direct oral anticoagulants, DOACs, work by interfering with the coagulation pathway to prevent excessive clotting. However, if these medications are not properly monitored or dosed, it can lead to an increased risk of bleeding or insufficient clot formation. 6. Liver disease. The liver plays a vital role in producing many clotting factors and other components of the coagulation pathway. Liver disease or liver failure can lead to decreased production of these factors, resulting in impaired clotting and increased bleeding risk. Thanks for watching.